Hello and welcome to today's Teardown Sessions. I'm Helen Lee, your host, and today we're going to be talking all about decentralized data with the guys from Ukama. Very excited about talking about that. But before we get started on decentralized internet, we have a few exciting announcements today. I've been waiting to give this announcement for some time. Let me add it to the stream now. So hooray, we have finally announced 2023 Teardown. So the last Teardown was in 2019. And for those of you that aren't familiar, Teardown is the festival of hacking and open hardware that Crowd Supply runs with PSU, which is the university here, and SETI, which is this community grassroots kind of creative tech group. So we come together and we run this awesome festival, and it's just been announced. We'll be putting the call for proposals up soon. But yeah, it's great. There's always a scavenger hunt. There's lots of great times. We hang out in hackerspaces. We share our cool projects. You know, it's a really, really great festival. So do keep an eye out for that. So that's my big announcement for the day. But I also wanted to take a quick look at what else is going on at Crowd Supply, because we've got some fun campaigns at the moment. We've got Lucas's MNT Pocket Reform. This is a little open source 7-inch laptop with great LED things. It's doing super well, nearly raised 200K already. We've got a lovely little USB, device. We've got PIEG. So this is a group that have come back. They've done some really cool stuff. It's an EEG and various biosignals boards. It's a cool little thing. Also fun, I really enjoyed the ESP360 remote, which is compatible with Home Assistant. And I'm sure that those of you who are interested in decentralized internet probably already know about Home Assistant, but it's a privacy-focused, open hardware version, alternative to Alexa or Siri or all of the other ones that will steal your data and do evil things with it. So if you're interested in that, take a look at Home Assistant and the various compatibility things that we have. And finally, before I bring on the guests, I wanted to give a big shout out to Qorvo, who have been doing some great stuff, but also they are sponsors not only of the creators that we're going to be bringing on shortly, but of various different things, including we did this cool hardware happy hour. So I run a hardware happy hour in Portland. It's one of the groups I run. It's lovely, pints and weird instruments and schematics on tables. But they sponsored that as well. That was cool. And they are sponsoring a giveaway on this stream. Okay, so I've got 2 Caribou lights to give away on this stream, which are very covetable boards. And Qorvo is paying for them, so thank you. And the way that you win your Caribou light during the stream is by commenting and asking questions. So as per usual, I have written down a timestamp, or today I've written down 2 timestamps on a post-it note on my desk. If your comment or question is closest to the time on my timestamp, then you will win one of the 2 Caribou lights that we are giving away on stream today. And yeah, so that's that. All right, so cool. Without further ado, I wanted to take you to, and these are also sponsored by Qorvo, or they're certainly supported by Qorvo, the fantastic team behind Ukama. So let me just remove this from my thing and then add on Kashif and Vishal. Hello, and welcome to our stream, both of you. How are you doing?
Pretty good. Thank you.
Do you want to introduce yourself to the audience, first personally, and then maybe the project that you're working on as well? Let's go with you first, Kashif, because you're on top.
Okay. All right. Awesome. My name is Kashif. I'm the founder and engineer here at Ukama, and I've been working on rural connectivity and decentralized network for about almost 10 years now. And we have an awesome team, which is all over the world. We're a distributed team. We build distributed network, and one of the colleagues here is Vishal. Vishal, you want to introduce?
All right. I can't hear you, Vishal. Or maybe. Oh.
Is it good?
Yeah, maybe it was. Yeah, I can hear you now. Sorry.
Yeah. Hey guys, I'm Vishal. I've been engineer with Ukama from past 3 years. So I mostly am working on the embedded side of the product, and recently started working with the backend part also.
Great. So Thanks for coming. Thanks for joining us. I'd like you to start off by explaining a little bit about the concept of a decentralized network. Like, before we dive into the technology that you've developed, let's take a little step back and talk about the genre in which it exists. So tell me a little bit about decentralized data, why it's important and why it's coming to the fore now, with the citizens broadband. If you could, give a little bit of background history into decentralized data, that would be really helpful. Am I reading? This is, yeah. Again, no, I can't hear you. You're not muted on my end. Super weird. This is. Hang on, I'm going to add you back in. Okay, do you want to say again? Can anybody else hear it? Nobody else can hear you either. There's no, can you like,
Can you guys hear me?
Yeah, kind of. You've got terrible audio.
Okay, hold on.
But I can at least hear some sound now.
Can you hear me now?
Yes.
Awesome.
Yeah. Can anybody else hear him? It takes a little, there's a delay on the thing, but I can hear you anyway. Anyway,
awesome.
back to decentralization.
Yeah, okay. Let's take another step back. Let's start with like, what is cellular network, right? So when you actually have your phone, when your phone always attached to a base station, right? Like what's known as a base station, a RAN. There are many names depending on if it's 2G, 3G, 4G, and now 5G, right? So that base station is always connected to a central core. Okay, so core element is mostly software element. This is where you run your policy. This is where you check your balances and all the stuff. And then from there, when it actually has admitted, then your traffic goes on the internet. Okay, so I'm just going to talk about the data only because voice and SMS is a bit of mess there, so we'll just stick to the data traffic, and that's how it works, right? So, for example, what does it like? Why is it a problem? Well, the problem is like, okay, if you need to add more node or more base station, only people who control the core can add more base station because it's a top down, right? It's like, for example, AT&T. If AT&T is building a network, AT&T is going to deploy more base station, right? If you want to add like your base station to AT&T network, then you have to have agreement with them. You need to be able to hand over all this stuff, right? It's a very top-down approach. Versus a decentralized approach would be like, for example, let's say anybody, just like the internet, can set up a tower, set up a base station, have a core, and be able to talk to another person who actually have done the same thing, and be able to roam from this network to the next, to the next, to the next. Okay, that's how, like, that's the main idea about a decentralized network. Now, why is that important nowadays? Well, we see like literally 3.5 billion people have no internet access. We even go outside like an hour north. So here in California, I'm actually in the Bay Area. There's no connectivity, and they cannot bring connectivity. Why? Well, because only AT&T or Verizon or these MNOs can actually build a tower. People cannot set up their own infrastructure when it comes to cellular. And I think that needs to be changed in order for us to move forward.
That's really interesting. Yeah, I've seen a number of citizen self-governed like data and Wi-Fi services from the different hacker communities I've been involved with in the UK and in Europe, and over there we've got these. You've probably heard of it, Freifunk, and the various. Each of the different countries has one, right? They're a citizens Wi-Fi that relies on mesh networks, right? But I was thinking when I first came across your project, I was like, well, that probably wouldn't work in America, right? Just for the you'd need a certain amount of population density to make decentralized Wi-Fi work. Am I thinking correctly?
Yes and no, right? So, okay. So the thing about the Wi-Fi, why you need a center density is because of the limited range of the Wi-Fi, right? So Wi-Fi, by the specification, you can only do 4-watt ERP, and that's it, right? You cannot really broadcast large, and because of that, you only have really smart, like lucky if you reach 100 meter, right? So you need a lot of these Wi-Fi access point in order to actually create density, and then you mesh them up, right? Great stuff, right? And why? Well, because it's based on the ISM band, right? It's an open spectrum that anybody can go, like you can buy like a couple $100 Wi-Fi access point and deploy and a couple hundred more and start building your own network. Now, the problem is, unlike Wi-Fi, cellular is completely different. Cellular is designed for larger area. It's more broadcast. Wi-Fi is more hotspot, right? Nothing beats Wi-Fi. Like no matter what I do, like even whatever people claim on the 5G, nothing will beat Wi-Fi 6, right? And the 7 and hopefully 8. You cannot beat that speed that Wi-Fi gives you, right? But the Wi-Fi has a problem, right? Couple of things, right? First is the range, okay? Because you're limited, you're working in the ISM band, you can only transmit so much power. When you transmit so much power, you can only reach so much. Okay, that's not the case for cellular. Cellular, you can really transmit high power, and you can go like kilometers. Okay, because you can go kilometer, well, all of a sudden you do not need like a couple of dozens of Wi-Fi access point to cover the same area. You just need one cellular base station.
I see.
That's one thing.
And can that reach a lot of people as well as the range? Is it, or is it limited on how many people can connect to that particular node?
Right. So there's two things. So one is the range, and then is the capacity, right? Well, the reason is Wi-Fi by definition is the occlusion avoidance protocol. What does it mean? If you have a lot of devices connecting to the Wi-Fi, it will back off, right? It will exponentially back off, and it will back off, right? So that's why during the rush hour, you see all of a sudden, even apartment building, traffic just stop, right? Or it gets really slow. Although the backhaul is not a problem, it's the access problem, okay? Now, when it comes to cellular is a slotted protocol. What does it mean? You are guaranteed you're going to get a slot as long as there's enough slot. So, for example, if you have like 60 concurrent user trying to access internet using cellular, you will always get more or less the same speed. You will have more or less the same latency. So it gives you that quality of service. So you can actually have capacity, you can have the range, and you can have larger capacity, right? But now, unlike Wi-Fi hotspot, where you get really high speed, now that capacity is, of course, shared among all of them. So that's the second fundamental difference between cellular. And
I think that's super interesting.
The third one is a handover. Yeah. The third one is a handover, right? Which is what we're so used to, right? So you're going down the road, you have the coverage from one base station, your calls are connected, and it will hand over to the next base station, and to the next, and to the next, and to the next. And or if you go abroad, like for example, AT&T doesn't work. AT&T, for example, have roaming agreement with a whole bunch of different operators. So your SIM will work. Okay, I mean, it's going to be expensive as hell, but that's a different problem. But it will work, right? So you don't have to worry about losing your connection.
Very interesting.
These three things would be the fundamental difference between doing the Wi-Fi and the cellular. But cellular do have problem, right? Remember, so the main thing is like, okay, everything is centralized. That's why people like start building Wi-Fi. Well, you cannot add node. Well, why? Well, because it's very central architecture, right? So think of what we're doing is a merge of both, like Wi-Fi access point where anybody can deploy it very easily, but have the benefit of cellular. Right? Have the coverage, have the more range, have the more capacity, but anybody can do this. And that's why we have to build a decentralized network.
Cool. And we've been speaking a lot here about the physical benefits of cellular versus Wi-Fi, but can you speak a little bit about security as well and privacy? Because I think that's something a lot of people are really interested in at the moment, right. And I think it plays in really well.
Right. So cellular by definition or by design, I would say, is actually based on SIM-based authentication, right? What does it mean? Like everybody has a SIM, and everything is encrypted over a layer. Okay. Unlike Wi-Fi, which doesn't have that kind of encryption. Okay. So it's more secure when it comes to cellular versus Wi-Fi. Second thing is like, let's say Wi-Fi, if you have an access point, like, okay, let's imagine I give a Vishal my Wi-Fi access point password. And if I don't want Vishal to not log into my Wi-Fi access point, I have to go change my password. But then this means I have to give this new password to 50 other people, right? Which already have, and it causes a lot of operational problem, right? So versus if I want to block Vishal, then I will just go on my dashboard and I will block Vishal's SIM. Okay, now Vishal will never be able to use my network, whereas other 50 people can continue to use the network, right? So there's a lot of this operational benefit that's not kind of available as of yet because Wi-Fi is based on the SSID, not based on SIM.
Yeah, thanks for that information. I've got a number of questions from the audience. I can hear myself. I've got to take my headphones out. It's terrible. Hang on. While I speak, I've got to take my headphones out. But lots of people are joining us, so hello to everybody, and thanks for helping us troubleshoot the audio problems right at the beginning of the stream. Leon's here, and thanks for Leon's another creator with Crowd Supply, and yeah, you timed it just right. You could hear everybody. TCAS has said that this is like the self-build ISP movement, but for cellular networks. Very cool. Or like Meshtastic for voice. We've also got a couple of questions here from Francisco saying, is the GMB expected to cover NB IoT and MCC service types? Also, wow, lots of questions here from Francisco. Good, let's get through them all. Is the MPHY level using variable numerology as in 5G? And also, is the channel coding scheme covering convolutional turbo coding, LDPC, and polar coding? Can't say that I understand all of those terms, but let's see what you've got. But before you go to these, there's a couple more questions here, and you can choose which ones to answer in which order. But another one from Francisco saying, are there any plans for massive MiMO, FR2 bands, etc., etc.? And a nice question here from Eric. Thanks for this question. What license is Ukama under? Yes, and I would like to talk about your approach to open hardware and open software and what you think it brings to a device like yours as well. But which question do you want to start with?
Yeah, we can start with Francisco. So I mean, so I think one of the things that Ukama stack is like we're not G Node B. G Node B is the 5G base station. This is E Node B, which is the 4G yet, right? So when you look at the Ukama, which we'll see in a minute, it's actually running in the back here, is basically an LTE release 9. So that's how we're starting as a 3GPP release 9. It can support very basic stuff right now. We are working on the G Node B, which will be released next year. So all the stuff around the 5G and G Node B will be handled next year. Sorry, Francis, you have to wait for it next year. But this is all LTE stuff right now.
And when you say it's going to be supported next year, is this like a software thing? Are you going to be
it's
releasing
a new
different hardware?
It's a new hardware, and the reason is because the chip that we use right now is this one. This is the SoC we use. It's the Marvel Cavium chip. This one. So this is our LTE E Node B. The chip that we use only currently support LTE. So in order for us to support the 5G chip, we have to redesign. Well, mostly this portion. This one is all power stuff, and this is your. Oops, sorry. Can't really see. And this is your RFIC, and this is your SoC. So we have to replace both of the. This one and this one. It's mirrored.
I know it's difficult. Pointing at electronics
exactly. So that's why we have to redesign a new board. Now that said, we have two things, right? So we do have the E Node B, or what's known as the tower node. We call it tower node because we don't want people get confused. There's many terms, E Node B, base station, RAN, all the stuff. We just said, okay, let's just call it tower node. Why tower? It's a node that goes on a tower. That's it. There's a home node. There's a node which is in the home. That's it, right? But you see the amplifier unit, which is one amplifying the signal. Those are all 5G compatible. So down the road, if you actually want to use G Node B or 5G base station, then you just replace the tower node with a new tower node, which is compatible with 5G, and you keep the existing infrastructure.
Great. I'm going to come back to the hardware and software licenses
Yes.
shortly.
Yeah.
But before I do that, I would like to say congratulations to Francisco with your last question here. You were closest to the first winner of the, my first timestamp. So you win a Caribou Lightboard. You're going to have to message me on Twitter, either Crowd Supply or my personal Twitter, which is Helen Lee, Leigh. And you can just send me your address and I'll send that out to you. Okay, cool. Yay, that's nice. Okay, now let's go back to software licenses.
Yes.
One of my Tell me about your relationship with open source. Like, why are you interested in this all, and what are you bringing? What are you taking?
Yeah, exactly. Okay, a great question. So let me tell you. So we started looking, at least me personally, when started looking into the cellular stuff back in 2010. There used to be a very famous project called OpenBTS. This was building the 2G. It was an open source, and I was like, whoa, that's great. I mean, that I think was the first cellular stack, and then on the parallel there was the Osmocom stack, which is again two really good stack, very different approach, but they were all open source, and because of that, it let me learn and let me contribute and let me deploy stuff and build companies out of it. So I thought it's a great model, and I should be just doing that, right? And I just love it. So in terms of what license is Ukama under? So okay. So one thing about Ukama's software is there are multiple layers in the software, right? So there's the bootloader, there's the operating system, and then you have the LTE stack, and then there's a core, and then you have a lot of services running in the cloud. And for example, that includes your subscriber management, your billing, all the stuff, right? So everything is open source under BSD license except the LTE stack. LTE stack is not open source currently, and the reason is because we actually got it from a third party, which we heavily modified. And because it's from a third party, which actually came from the chip vendor, the SoC, we cannot open that stack. So that's except that, and the hardware is CC BY license. You can actually look at all the hardware code. You can modify. You can do anything you like.
Have you seen the CERN open hardware license? That's my favorite open hardware license.
I have looked at it. We have not, to be very honest, right now, if you look at our GitHub, it doesn't have a license, which I think I should fix that very soon.
Maybe.
Yes. So yeah, absolutely. Yeah.
Great. Okay, we've got another question here, which is actually one of my questions, but nicely worded. Thank you, TCAS. Is asked, is it up to each base station owner to handle all the administration stuff, or how does that all tie into the network? Is there an admin? So if somebody is listening and they want to run their own network, what does that actually involve?
I think it's a great question. Yes. So every network that's been built is completely autonomous. Okay. There is nobody actually. We're not monitoring. It's your network, right? What we do is let's imagine what's the like internet, right? So you build a network. You are responsible to managing that part of the network. Okay. What we do is we provide all the protocols and the stack so people can run that, right? So for example, you as in define the billing. We do not define the billing. You want to charge people, you want to leave it open, or you want to say, hey, I want to do it for free, or I want to charge them $100 per gigabyte. Again, it's all up to you. You want to have add SIM, you want to block SIM, you want to upgrade SIM. It is your network. We have nothing to do with it, right? So what we do is we build the technology. And we build a protocol so that, for example, your network and somebody else's network, and if there are a customer who wants to roam from your network to the other network, assuming both of them has enabled them by yourself, you can actually block saying hey, I don't want any other customer to roam over to my network. That's your decision, not ours. So you can say hey, no more roaming. Or you can actually block your own customer, say I don't want my customer to go roam to somebody else's network, blah, blah, blah. That's all up to you. We do is provide that interoperability layer. We build the tech for you.
Yeah, interesting. I was going to move on to the demo, but there's been a great question asked by Tony. Because I wanted to talk about bands, right?
Yes.
There's been some incidental talk about bands, but I think we could dive into that a little bit deeper. So Tony's asked what radio band is used, and presumably people need the radio license. I think this is a really good point to talk about the citizens broadband and what that means and how this has enabled you to do what you're doing.
Exactly. I think it's a great question. So one of the things that was like, so as I said, like I was been doing this for a very long time, and one of the big problems we had was the spectrum, right? And that's the thing that the MNOs has. Like that's why people start building Wi-Fi, and the reason is because you don't need spectrum. You can build stuff like without like asking anybody permission. So I think what has changed in the last few years is basically US has opened up what's known as the CBRS band. Now, CBRS band actually has 3 tiers. So first is like, it's actually owned by US Navy. That's the primary owner of that band is the US Navy. So if you go to the certain ports, that whole band is blocked. And especially when the US Navy ships comes in, then they take over. So they're the primary owner of the spectrum. Okay, so what FCC says, okay, well, we have a lot of bands, so we actually tear it down. So primary owner is the US Navy, and then you have 2 levels. One is the PLL, which is basically you pay a fee to actually get a chunk of spectrum, so you own that. It's like you pay that. And the second is a GA, which is general availability. Okay, how does it work? There's a FCC certified database. I think in US right now there are 6 or 7 of them already, and there are a couple more coming, where you can actually register your base station or yourself as a person and say like, hey, I'm going to deploy a base station at this location. It has this output power. It has this antenna radiation pattern. Allocate me a spectrum. Okay, and they will allocate you a spectrum for a very small fee, like a couple of dollars or maybe a couple of tens of dollars, and that's it, right? And now you can actually legally run your own network in the CBRS band here in the US. Then the question is like, okay, what all supported in the CBRS band on the handset side of things, right? Because if you build, like from the base station point of view, you can work in any band, but if your handset doesn't support that band, this is useless. So good thing is that all the newest phone actually support that band. You get like, I think it was starting from iPhone 11, started at CBRS band, although that band was not open back then. But now, like you go back a couple of years, all the new smartphones support that band. So that's what's happening in the US. In other places, there are a lot of spectrum.
Just if anybody wants, I've linked in an article about what you just said.
Yeah, exactly. Great. Yeah, thanks for that. And then when you actually look outside the US, and there's like, okay, what happened outside the US? Well, there are a lot of countries actually follow that. And although CBRS is known more worldwide, it's like always an open band, but you go to Australia, okay, you go to Australia, you submit like $40 or $50 something fee per year, and you get a 1800 megahertz band. Wow. As much as you want, right? So they have 1800 megahertz and 2100 megahertz, which is again supported by a lot of handsets. So you can build your own network in Australia. Same goes for New Zealand. New Zealand has 3.4 to 3.8. You go to Canada is opening up a CBRS equivalent band. UK, you can go to Ofcom, you can file in, although they have all the filing thing yet, not automated, but you can file in and you can get your own band for your private use.
I know that.
So is France. Exactly. So
they did it was only 2G, it was like GSM. They did a DIY phone cellular network at Exactly. And it requires paperwork, but you can
which is weird. But I think to their point is like, hey, we do not even know yet if there's a demand yet, right? So as the demand start pouring in, they will have to automate because I don't think they can sustain that paperwork. And the main problem was the lack of cheap hardware, right? So hopefully this will help. So now, so you have a lot of other countries which are opening up, and in some places, we actually partner up with a local spectrum owner, and we actually say, hey, you're not using the spectrum. Let us use the spectrum so we can actually help people build the network. So we have those agreements in a couple of countries in Africa. So yeah, I mean, things are opening up pretty good.
Super interesting. I've got a follow-up question from TCAS. He says, to have a phone that would work on the Ukama network at home, but need to hop on it networks when away, you'd need a second SIM or eSIM. Is that correct? Or are you is it possible to roam?
Yes. So definitely. So the way it works is like, and the way actually we're doing right now is, you do need two SIM. One SIM will be used for Ukama network or your Ukama network. Again, remember, this is your network, not ours. So you use that as a SIM to connect to your network. And as you go outside the coverage, it will go back onto AT&T, for example, if you have that SIM, right? So you can use your carrier SIM for your voice and SMS. And when you're outside of your Ukama network, and when you're on Ukama network, it will still use that. So yeah, we have the roaming capability where it can roam between back and forth. Yeah.
Interesting. Yeah. All right. I think it's time to get a little demo. How are you feeling, Vishal? Are you ready for us? Yeah. All right. Awesome. So shall I share your screen, or do you want to show the things behind you first?
Yeah, go ahead. You can share the screen, and meanwhile.
So explain what we're going to have a look at here first. And maybe you want to point at the wall behind you, Kashif, as well.
Oh. Sorry.
Yeah, there we are. Look.
Okay, so what we have here is like our live demo setup. Like we have our base station running. Like if you see this part of the board, we have our baseband section. Then here we have our front end section, which is basically the RF part. And then you can see the bunch of antennas on top. And everything is powered by the PoE supply, which you can see here, which is also our switch. And you can see the front ends connected and the baseband section connected to the PoE switch, and then which is connected to our EPC.
Just to jump in here. So the one you see in the bottom is a tower node. Is this guy? Oh, sorry, here's the camera. Is this guy? This is the tower node? That's what you see right. Where is it? There. So that's the tower node. And then what you see on the two on the top is the amplifier unit. These are the amplifier units, and that's what you see right on the two of them on the top.
Yeah, I see. All right.
So that's something that will go like on the tower.
Yeah. So you have the base. This is the cover open. So that's the tower node, and those are the amplifier units. That's exactly the setup we have.
Perfect. Perfect. All right, let's look at the code. Let's give it a test.
So currently, like I have put a mode on cell phone on the flight mode, and I'll just ask it to connect to our network, which is basically a test network with the PLM. So in the background, you can see in a Wireshark, it's trying to connect. Basically the cell phone is sending signal to our base station. And base station is kind of like doing the authentication session and establishing a session with the phone. So as of now, you can see like we already got a 4G coverage, and meanwhile there was some messages turned on the background, and I'll do the quick speed test just to show like what we are getting.
Yeah, and by the way, this is over the air. So this is a phone which is wirelessly over the air connecting to that base station using those antennas.
Oh, wow.
So we have intentionally put in a low power because we're using a different band right now, and we're in that city. So that's why. Yep.
So as of now, I'm getting like I think around 60 Mbps on a downlink, and then around 16 to 18 Mbps on uplink. But that's more of limited by our internet speed. So
I think that's better than my Comcast at home.
Yeah,
that's not saying much.
If I do it on a local run, I might find a better speeds on the uplink for sure. Let's do that. If I test it locally.
What's this Libre speed? Is it an open source internet speed checker?
Yeah, so that's basically I'm running on my EPC. And then it's testing it with the local within the local network itself. So that's where I'm getting like 63 and 40 Mbps on the uplink.
Nice, very nice.
So yeah, this is what we had from the demo.
Very cool. Let me remove your screen. That was really interesting. Thank you. I actually do want to talk to you about the code a little bit here. obviously there are many parts of bringing a product to market. There's the hardware, and there's the writing all the copy for it and making the the outside of the packaging, blah blah blah. How far are you along with the firmware and software that you had in your mind for launch? Like, are there any things that you're like, oh, I'd really like to work on that, but you haven't gotten around to yet?
Yeah, so I think just like I mean, we're a bunch of engineers at heart, right? So that's what we do.
That's why we're here.
Yeah, exactly. And just like engineer, we're really bad in project management and predicting. Oh, we're gonna get this thing done tomorrow, and then reality hits and it doesn't get done tomorrow. So we are as of right now, we're around a month and a half to 2 months behind our anticipated schedule on the software side. And because of all the stuff happening in the hardware, we have a lot of huge problem with the supply chain. So we are actually, the third revision we have done is basically redesign a bunch of our board to get rid of all the parts. And we thought last year, oh, this is it. We're good. We're golden. Until we have to redesign again, which we'll update to the community in December. And hopefully that's it and no more there. So we spend a lot of.
Do you have all your parts? Like,
we do.
Do you have them in hand? Yeah.
Not yet. That's the problem, right? That's the problem.
Oh wow.
Yeah, exactly. So hopefully, so that's where we are delayed. Is basically getting to the point where we can say like, okay, this is all good. So in terms of when we think we'll be ready, we're still aiming for September. I think we're on still because we put in some buffer in there, so we still think we're on track, but we might, we'll see. We might slip like maybe a month or so, but we're trying to get it done sooner as soon as we can.
Actually, I do have another manufacturing question for you. So I noticed on your project page on Crowd Supply that you've got some funding from the US government, which meant that you have to manufacture in the US.
Yes.
Now, obviously, I talk to a lot of different people who are making all sorts of different hardware, and it's been tough times over the past few years with this whole lack of anything that you might want, right? Yep. So I was wondering how different it's been manufacturing in the US exclusively versus, like, I don't know, you probably have manufactured in China with many different projects. So I'm curious about your manufacturing journey, particularly given the tough times that we're in and the fact that you have to manufacture in the US. So give us some gems on that.
So I think, so one of the things which was, so before all the projects, even when I was working on the Open Cellular and even before the stuff we did was all done in China. I mean, that was the thing, you send your file and you get the boards back. And that was good.
Pre-tariff.
Exactly. And then things start getting really bad. And we thought, okay, well, we should start looking stuff locally. And I was actually very surprised. So we did this extensive talk to a lot of manufacturers here in the US. And I was very surprised that the price difference when we're actually doing the assembly, not the PCB. So PCB is still cheap. Like PCB, when you actually get done PCB here in the US, is at least 10 times more expensive than if you do in China. But when it comes to assembly, like PCBA stuff, is actually more or less the same price.
That's interesting.
Yeah.
And of course, if you're getting your board assembled locally, that means that you have a country of origin for those. Country of origin. Let's say
actually, we were initially
country of origin, correct?
Exactly.
But if you're getting them assembled in the US, then your country of origin, of course, is most likely to be the USA, which means you avoid the nasty China tariff on import, right?
Exactly.
So
and then we build the boards, and then we build the box, or we get everything assembled. So then the PCB just become like a part. There's a lot of, like, we on our eNote B, we have literally thousands of parts. It just become one of the parts coming in from the manufacturer, and it's pretty good. So then we avoid the whole tariff. Now the major problem in the manufacturing is still lack of the parts.
Of course.
Especially the RF parts. It's just
my goodness. It's tough. I know a lot of people in your industry, your genre of this industry, are having tough times. I just got a delivery of FPGAs into the office, and I'm holding on to them with like dear life. I feel like we might get burgled just for the FPGAs.
Yes.
Like.
Yep.
Okay. More questions. I've got lots of things. Oh, so another thing I wanted to ask you was, okay, so a lot of these opportunities have been opening up because of the Citizens Broadband network, which I would say is experimental, i.e., like, you know, they started it in what, 2015 or around then, so it's quite new, right? So I was curious to hear about what the uptake's been like within the community, whether it's just a hobbyist thing or whether people are actually starting to use it. And I'm also curious to know what you think is the future of decentralized cellular and Wi-Fi in this country. Like, where do you see it going?
So they started the CBRS back a couple of years ago, but officially started in 2020 or 2021. So I think 2019, 2020, I forgot the exact year. But that's when the FCC just opened up and said, like, okay, now you can actually go and run your stuff legally. And to our surprise, I mean, we actually are talking to a lot of customers who are enterprise customers. We have robots, mainly around agri-tech. You have a lot of robots in the farm, and by definition, when you go to these farm areas, here in California, Oregon, the whole West Belt, Washington, the cell phone coverage is really shitty. Right?
Yeah.
It's like, well, they didn't put the towers there because there's nobody there, and like, okay, leave the farmer alone. They don't need internet, which is pretty bad. But anyway, so you have all these robots now in the farm, and what they need is connectivity, right? So first of all, there's a lack of coverage, and the second of all, the quality is not good because you're right at the edge of the existing cell network, so your speeds are not good. The third is, and this gets very interesting, is when you get to robots, all the existing telcos, towers, they are downlink heavy. What does it mean? That's why we saw the speed here when Vishal said, we're not getting much of uplink. Well, everything is downlink heavy. Right? Usually it's 1:5 ratio, but in robots, what they need is uplink. Right? They don't want to download stuff. They want to upload stuff.
They're not watching Netflix.
They're not, sadly, not for now. Maybe in the break time they will. Who knows, right? But they're not. So they need a lot of uplink, right? So this is where people start looking like, okay, maybe there's an opportunity where we can use the cell network in the enterprise. So there's a lot of take there where people just want to build a network because now their companies really depend on communication, or they are being slowed because lack of communication.
Yeah, really interesting.
That's what's happening, right? Mostly in robots, yeah.
Mostly robots. That was not the answer I was expecting, to be honest with you.
Yeah. And then when you look outside, outside the US, then it's mostly people, right? They just want to connect to the internet. There's nothing there, and they're like, oh, screw all the existing telco. We're just going to build our own network. So in the future, I think there's a great, it's a really good opportunity for us to build a completely decentralized network, which is not heavily. So the way, at least in our head, what we're thinking is like, okay, as more and more people start deploying this network, you still need to have. I think someone asked that question was like, okay, while you're in the coverage of your own Ukama network or someone else's Ukama network, that's good, right? Because you're in the coverage, but that will take maybe a couple of years when you have coverage nationwide, right, for Ukama network. So what happened to then? Well, you still need the connectivity from the existing telcos, right? So to blanket it, which is already there. So I think there's an awesome opportunity to build a network which is future ready, is built by people for the way they like, and rather than in a top-down approach by a couple of companies in the country. There are only three major operators here that we know of, right?
I did want to ask about the three major operators. Have they pushed back at all against this idea of a citizens network, or is it they just don't care about it?
No, I think what's the right word? So they think they are too big, and this is like nothing. It will not mean nothing, and that's why I think when people start building this network, only then they probably see the threat, because everything is like, everything is over the top, right? hardly people use I'm sure that people still use voice and SMS, but mostly everything's over the top, right? You can use WhatsApp, you can use whatever best tool, and Twitter, and everything's over the top, right, nowadays.
Yeah.
And what you need is just a data pipe. That's all you need.
Yeah, I guess you've got to figure out how to do the roaming between citizens broadband and the big telcos.
Yeah.
That's kind of a problem that needs solving, because not everybody's got 2 SIMs, you know.
Yep.
But I'd be really interested to see if they'll cooperate with you all later on. Once do you know what I mean? Have you spoken to them at all, or are they just don't?
Not yet. Based on my experience, because I work with them quite a lot. Based on my experience, it's not a good idea to work with them. Let them be, and then we build something with the help of people.
Interesting.
And I think we are actually working on just a single SIM. With some sort of a geofencing where you can actually move between the 2 networks. But we can do that without even talking to them. Why? Well, because there's actually telco aggregators. You can actually go to those aggregators and get the SIM which will work on AT&T without ever chatting with them. Which is, I think, is a good idea. You don't chat with them. They just waste your time.
TCAS has piped up in the comments saying, as long as you don't touch their utility pools, they don't care so much.
Yeah.
Which is kind of funny. And with that comment, you have won the second Caribou Light that I'm giving away on the stream. So please get in touch by Twitter, or message me some other way, and I will get you out that Caribou Light. So thank you for your comments and questions. And I did have another question here from Francisco saying, what is your take on the URLLC paradigm for factory automation? I'm assuming URLLC is some kind of communications protocol or something. I don't know.
I'm not sure what is URLLC.
It's the ultra reliable, low latency communications, which is a subset of the 5G network architecture.
Yeah.
Not ashamed to say, I just Googled that.
I mean, low latency. Yeah, I think it's very important, right? And the reason we do the low latency is because putting the core right on the base station itself, right? So because the control is actually on the base station, we actually remove the whole control latency requirement. So for example, if you have 2 robots, and this is one of the use cases, is if 2 robots which needs to communicate with each other in the traditional architecture, you go to the base station to core to the internet, all the way back down, right? Now they just communicate locally. So you have really low latency compared to existing telco, and that's one of the driving factor of people. Companies adopting in the enterprise industry, where they want to adopt this for their own use because of low latency, guaranteed latency. I would say that it's going to be like whatever, 40 milliseconds or 80 milliseconds, no more. Always going to be the same, and then you can communicate locally without having anything. So if you do not have even a backhaul, it can still work.
Interesting. Yeah. And if you were using a telco for the similar piece of work, what was the latency comparably? Like, are we talking a huge difference in latency, or by doing these communications locally?
It varies, right? So it varies where you are on the edge of the network, and more importantly, I think and this is actually one of the customer we're talking to. Like, they actually have these robots, and what was they telling me? Literally, when they get into this spot and there's no coverage, and they just stand there and do nothing. It cannot. The
robot stands there.
Yeah, it's there, and they have to send somebody to push the robot to go into the coverage, and then it goes on, right? It's like okay, because they cannot control where the coverage is, and because it's a base station that's very far away, and sometimes it's like really shitty, or maybe sometimes it can be in the shadow of a metal building. It just stops. It just nothing they can do about it. Right? Versus when you have your own network, the environment you're working in. You can deploy where you think you need the connectivity and how much you need and all the stuff. So then you don't have this where you need to push a robot. I mean, it's supposed to be autonomous. Now you have to do manual work, which is okay, I guess, but it's something that's not effective.
Super interesting. Francisco says that he agrees, and that small networks where small factories, even mid-range, will not play Nokia for a private network.
Yeah.
And he says that the holy grail would be 1 millisecond E to E 99.9 recurring error-free.
Yeah.
Interesting. Cool. And where do you? Oh wait, hang on. Don't have Twitter, but message you on Discord. Oh, that means I've got to log into Discord. One nightmare. All right, I'll sort you out. Don't worry. Okay. We're nearly at the end of the stream. We've got like 10 minutes left, unbelievably. Is there anything that you really want to share in the last 10 minutes? And particularly if there's anything, like any help you want, right? So you've been working really hard on bringing your upware up to date and using available components. So obviously, like everybody else, you've been redesigning everything while swearing at the car manufacturing industry.
Yep. That's the sad reality.
So is there help you want? Like, can we like plug your GitHub? You know, do you want like specific things like? Absolutely. I think there are a couple of things, and my wish list is like very long. Like when I ask for help, it's like, okay, the very first thing is like, okay, if you guys can give feedback, it's like, hey, I would love to have certain feature in a product, or like, hey, the way you're thinking is different. Maybe you could think about this. Like just a general feedback. I think that's just extremely valuable. Nothing beats that. GitHub. What's the handle?
Ukama. Yep.
I'll find it. You keep talking, and I'll find it.
And so that's I would say like that's the best thing. Like if you can think like all these questions are just amazing. So if you have any suggestion, that's welcome. Then the second thing is like all our hardware files are open. So if you want to look at stuff and give feedback, suggest improvement. That's always good. I think the more people look at stuff, the better it gets, and that's the whole idea behind open source. If you want to contribute, you want to extend, that's of course is always welcome. And then on the software side, we are, as I said, like we are. Yep, there you go. So we have two. This is the first one, Ukama. This is our software stack. A bunch of stuff here. You can see the system. And it's heavily underdeveloped. This is the OS. That's the OS based on the kernel. Linux kernel, and then we build a whole OS around it. Nice. Again, still work in progress. There's a lot of work left here. And recently we start using issues. So yes, I mean, feel free to look around. Feel free to suggest stuff. Feel free, that's the Ukama node is our hardware stuff. So nice. All our mechanics are also open. If you have stuff nice. Like, hey, you should have done this thing differently, or maybe this is better for thermal. Absolutely, we'll love anything.
Fantastic. And where do people follow you on the internet? Do you have Hackaday profiles, Twitter, blah blah blah?
Yeah. We not all of it, but we do have Twitters. You'll find us on our website, the Twitter handle, and we have LinkedIn.
And GitHub. That's where
and GitHub. So GitHub is the best. I think if you give a star, create issues or just suggestion or want to say hi, that's all.
There we are. I've just started myself.
Yeah. So we have two. So Ukama nodes is all the hardware stuff, and the Ukama is the software stuff.
Brilliant. Ooh, what else do I got on my question sheet? I've got to read my own handwriting here. Oh yeah, so I wanted to talk about your. You did mention it briefly earlier. Your plans for future hardware. So what are you supporting right now, and what are you planning to support after this one has been delivered?
Yep. Yeah. So right now is the what's known as 3GPP release 9 LTE. So that's the current version we're doing, and then later on, what we're also building is these end devices. So, for example, we're building these CPEs that can very small, and then, for example, you can even add 4 LTE module and increase the capacity, the download speed. For example, you saw like you got like 50 Mbps down. You add 4 of these, you can get 200 Mbps down, right? So there's a bunch of stuff that we're building. I think we're gonna hopefully launch and cross-apply very soon. And then next year is we're going to work on the 5G stuff, right? And basically start looking into 5G. But before we actually just like jump that bandwagon, we want to basically gather feedback from people, like if it's meaningful for them, or it's just like one of those things which is like maybe just don't need it and LTE is good enough. So we're still a bit early on. We have locked down. Well, I would not say locked down, but we're exchanging with different SoC vendors. So those feedback will be welcome.
Is this your first big customer-facing product? Like, or have you done this all before? Is this you an old hand at all of this?
Yeah, so we've done this before. So a little bit background. So this is my second company. So the first company was in Daga. Was co-founded with Shadi and Curtis. They are now. Shadi is a professor at University Virginia Tech, actually, and Curtis at University of Washington. Really nice guys. And so that was the first company in Daga, which were building the GSM version of it, using commercial off-the-shelf hardware from Range Network and building our stack on top of it. And delivering that to the user, which was acquired by Facebook. And then at Facebook, I started the Open Cellular project, which was purely open source hardware. That got, I think we announced that 2016, summer of 2016. And we did a bunch of deployments everywhere around the world. That was mostly started as a project which was for the community, but then started gearing more toward the MNOs. And then in 2020, that's when I left Facebook and shut down the project. And this is the second version of my first startup. So it's a continuation of that. Yeah.
I didn't know this. I mean, how much I hate when I can hear myself with a second delay. It's terrible. How much of Ukama is an iteration of the work that you've been doing, in open cellular? Right. Is that influential?
Yes, definitely. I mean, so in the open cellular, we start building the LTE. So the board that you saw here, this one. So a version of this board was built as part of Open Cellular. So I used that, and that was open source. And there are a couple of actually companies who took the Open Cellular hardware and they built a product out of it, and we're one of them. So that's cool. Absolutely. I mean, that was the whole idea of actually open source the hardware so people can just learn from it. Yeah. So this is we learned quite a lot from Open Cellular, but it's completely redesigned. And the reason is because that was designed geared toward the operator. This is geared toward the people. So when you do that, it has certain features that's not needed by the operator, but it's needed more by people.
Super interesting. Yeah. All right. Well, it is only a couple of minutes till the end of the hour, so I'm going to wrap up by saying thank you so much to my guests, Kashif and Vishal, and also Vishal, you just did a live demo and nothing went wrong. Like, that's like snaps for that, man. Like snaps for that. Like, I've had live demos fail all the time. So every time it goes well, you need to be applauded. So well done. You did a successful live demo. But yes, so thank you both for coming on stream and sharing all of your information. I would love to have you back on later on in your manufacturing cycle to find out how it's all going and your plans for the future. And again, like how the firmware's going,
No more versions.
Yeah, absolutely. So again, thank you very much. And thank you to everybody for joining us today and your interesting questions as well. Yeah, for Francisco, you've particularly given us some really interesting things to talk about. So thank you for that. And just a reminder for those of you who are West Coast or don't mind traveling, that this summer in late June, we will be hosting Teardown, which is our festival of hardware hacking and open hardware. That is announced. If you go to crowdsupply.com, there's a big banner at the top, and you can find more info about that, with more forthcoming once I write it. But we'd love to see you there if that's possible. Also, a little shout out for if you are local, I'm running Sound Hackers at the CrowdSupply office next week, which is all about sound hacking and making DIY instruments. So if you're interested in that genre of open source hardware, you can find us on meetup.com, or you can find us through the CrowdSupply Twitter, blah, blah, blah. But yeah, Sound Hackers, that's happening next week. And next week there won't be a stream because I'm going to be in Santa Barbara for LatChip, learning all about what's going on in open source chip design. So it's going to be very interesting for me. I'm particularly looking forward to catching up with Tim Ansell and the Open Silicon people. So I'm very excited about that, and I will tell you everything they've learned. But yes, thank you so much for joining us. It was a delight, and I will see you again in 2 weeks. Okay, thank you, everybody.
Right. You guys,
Bye.
thanks. Yep.